What's going on, everyone? And in this lecture, we're going to be going over VLANs. So again, now that we're getting into some more configuration, we're definitely going to dive deep into the technology, the fundamentals of it. But a lot of this section going over VLANs is going to be doing our VLAN labs as well. Because the truth of the matter is, in IT, you need hands-on keyboard to stay relevant and to get good at your job. So with that being said, let's go over VLANs. So they stand for Virtual Local Area Network. And what a VLAN is in one sentence is a 4-byte tag inserted into the Ethernet frame to logically segment traffic. Okay? So what do we mean by this? So as we can see here in some of our pictures, we have these VLANs for our different devices or maybe different departments even assign their own subnet. And the way we logically segment this traffic at layer 2 is we come down here to our Ethernet frame and we insert a 802.1 tag or 802.1 data in there, okay? So again, this is our IEEE standard for 802.1q frame. We insert 4 bytes into there. And in those 4 bytes is going to be an actual VLAN ID. So that number actually does get inserted into our Ethernet frame. So when this switch receives traffic, it's going to tag traffic from, let's say, this computer here with that 802.1q header, and it's going to correlate to that VLAN ID. So then when that traffic maybe has to go up to a router or to another switch, all traffic coming from that computer is logically separated from, let's say, these printers or this VoIP system, which is going to be tagged with an 802.1q header with an ID of 7. So again, just going over our bullet points here. A 4-byte tag is inserted between the source MAC address and the Ethernet type field. That's that type field right here. And then through this technology, we can separate traffic locally on one switch, or we can segment traffic logically that spans across a huge campus area network, okay? So think about like our 3-tier core topology. These are distro switches. And then we have all of our access switches here. Right? We could have computers over here on VLAN 5, and this could be like the sales department, and we could have computers over here, also a part of VLAN 5. So in our layer 2 environment, we can have these VLANs span across all of our switches and all be a part of that one network or that one broadcast domain. You may be wondering, okay, so that makes sense. A VLAN is just essentially an 802.1 tag that gets inserted that can separate traffic and tag it, literally tagging it, saying it's part of this numbered VLAN. But how do we determine the numbers, or what do these numbers mean? And how do we assign and create? So we're going to get into that. And before we do that, I just want to show you what life would be like without VLANs, right? If we wanted different broadcast domains, we would need hardware for each traffic that we tried to separate. But with VLANs, you can see we can now move that into a logical plane where we can have this traffic segmented on all of our switches logically. Okay, now let's go over some VLAN standards and let's go over the numbers. So the standard range for VLANs and the VLAN IDs is going to be 1 through 1005. That means if you want to use standard range VLANs, you can use any one of these numbers except the default ones, okay? So let's go over some of these default ones. First one I'm going to talk about is these numbers down here, 1002 through 1005. This is for legacy technology, and you're really not going to see this in use today on the enterprise, so we're not really going to talk about this. One thing we are going to talk about is the VLAN number 1, which is always the native or default VLAN. So a couple things about VLAN 1. Out of the box, a switch is always going to have VLAN 1 as the default. And that native VLAN, as we call it, is going to carry control plane traffic or layer 2 control plane traffic. So what does that mean? So protocols that we're going to learn about like CDP, VTP, DTP, this is all part of the control plane and kind of sending information between our layer 2 switches or our switching environment. All that traffic is going to be carried across on VLAN 1. So the Ethernet frame that's going to carry this control plane traffic won't be VLAN 5, 6, or 7. By default, it's going to be the native VLAN 1. And then 2 through 1001, those are going to be VLAN IDs that you can use for any way you want, right? So you have the administrative privilege to say, okay, all of our phones are VoIP systems with VLAN 20 in our network. And let's say we don't have a bunch of departments, so we just have a data VLAN that's going to be number 10. Another little note down here. So if you've been watching our videos in chronological order, you know that we have gone over the boot process and the hardware of our switches and routers. So if we were just to draw like a little motherboard here, right? You know that a switch doesn't have a traditional hard drive. It has something called flash, okay? Put an F right there for flash. And that flash is essentially the storage for that device. And in that flash, you're going to have the iOS, NVRAM, right? Those are actually going to be like in their own directories, their own data in that flash that stores it. So when you create standard VLANs and you save your configuration after you create the VLANs, you would assume that all configuration always gets saved in the NVRAM, right? Or your startup config. And that is true, except for standard range VLANs. They're going to be saved in a different directory on the flash called the VLAN database, which is VLAN.dat. So if you were to look at your flash and you've created standard VLANs and you do a command called more flash : you're actually going to see the VLAN database as a separate like folder directory from the iOS or the startup config here. So in our I think our first or second VLAN lab, I'm going to show you how to delete this VLAN database just to kind of show you how these standard VLANs are not saved in the NVRAM or the startup config. Okay, and then we have extended range of VLANs. These are going to be from 1006 to 4094, and these are going to be saved in NVRAM. When you create a standard VLAN or an extended VLAN, the configuration and syntax is the exact same. So that's really the only main difference is where they're saved. Okay, now let's go over some different VLAN types, and this is going to be important for the exam and real world, guys. So you have just your access VLAN, and this access VLAN is any VLAN number or tag that's just encapsulated for what I like to call regular traffic, meaning non-VoIP systems, essentially. So your printers, your computers, your servers are going to be configured as access VLANs. Now, this vocabulary and terminology may get a little funky. And what do I mean by this? Well, for you guys that have worked on enterprise and live networks, you know that people sometimes say, oh, that's the server VLAN. Well, what they mean by that is that's what that VLAN is used for. That VLAN tag is used for our server farm or server cluster. But if you look at the Cisco documentation, an access VLAN is used for anything besides Cisco VoIP phones. So when you're configuring that VLAN, even though it's your VLAN you're going to use for your server farm, you still type in switch port access VLAN and then a number on the CLI when you assign a VLAN to a switch interface. So yes, we could say, oh, that's our sales VLAN. That's our data VLAN. That's our server VLAN. That's just a name to describe what that VLAN is used for or what devices that VLAN is used for, but they're all access VLANs. They're all there so that endpoints can access our network, right? It's kind of how I like to think about it. Then the voice VLAN is something special to Cisco. So the voice VLAN is a configuration option to segment your VoIP traffic from all your regular traffic or your data traffic. So that VLAN tag actually marks and classifies VoIP traffic and is segmented from the rest of the network, okay? So literally, like we see here, you can assign a voice VLAN and an access VLAN to one switch port, and you're going to tag this VoIP traffic, right, with that VLAN tag. And then that VoIP phone, that Cisco VoIP phone, should have like a little switch on the back that allows you to plug into the switch and then plug a device like a laptop into that phone. And then when this traffic reaches the switch, it tags it with the voice VLAN. And when this data traffic comes through here, it's going to come untagged. It's going to hit this VoIP phone and then get tagged with whatever the access VLAN is. Okay? That's something unique to Cisco. So if you're using VoIP system that isn't Cisco, but you have Cisco switches, you wouldn't really need to use that voice VLAN because, one, it uses the Cisco Discovery Protocol to discover there's a Cisco VoIP system there. So it's really just not compatible. So like we say here, voice VLANs use CDP to communicate that there will be an untagged packets from a connected device that will need to be tagged with the native or access VLAN. So essentially what that means is, hey, switch, the tagged packets you're going to get are for me. The untagged ones are the computer or endpoint that's connected to me. You need to tag them with the access VLAN we set up or the default native VLAN. And we're going to see this in the lab as well. Okay, and then the native VLAN. So this is the out-of-the-box VLAN that will tag all traffic that is not assigned to a different access VLAN you created. Another important thing about the native VLAN is that it also carries control plane traffic like CDP, VTP, DTP, okay? So that's going to be important. We're going to look at this in our Wireshark captures as well, but the native VLAN carries that control plane traffic. And then the last VLAN we're going to go over is one for security, actually, and this is known as the black hole VLAN. This is when we have ports that are not used. And what we mean by that is there's no endpoints plugged in to that switch port. So what we're going to do is assign this a random VLAN number that doesn't have any subnet assigned to it or doesn't have any network access. So let's say we have a malicious user just plugging into our jacks on the walls and we decide not to shut down any of our switch ports. What they're going to get is just a black hole VLAN that gives them no access to the network and no ability to do a VLAN hopping attack because they're not going to get tagged with the native VLAN as well. So it's just for security purposes. So when someone says, what should we do with unused ports? You could say shut them down or put them in a black hole VLAN. All right, and then last slide we're going to go over is VLAN configuration. And we're going to go through this kind of quick because I'm about to spin up a lab for you in the next video and do our first VLAN lab and go over these commands. So the VLAN configuration is really simple. You go into global configuration mode, type in VLAN and then a number, and then you can also give it a name here. And that's just for administrative purposes, so we know what the VLAN is used for. And then important, you have to type in exit for that VLAN to actually be created. And then when we want to assign or create a VLAN from the sub interface mode, we go into the interface we want to configure. We tell that switch, hey, switch port, you're going to be used as an access. This switch port's mode is access. So any endpoint that connects to you, you give them access to the network. Switch port mode access, okay? That's the first command we do. And then we're telling that switch port, hey, switch port, you're going to be a part of access VLAN 55. We're telling that switch port what access VLAN to be in so it can tag traffic with this VLAN ID. And then we're also going to give it a voice VLAN. So now we're telling it, hey, switch port, if a Cisco phone or VoIP system plugs into here and you receive that CDP traffic, you're going to tag it with VLAN 40. And as you can see here, if we didn't previously create that VLAN, it's going to create it for us. And now if you look over here to verification, we have a couple commands, show VLAN, show VLAN brief. As you can see here, this is going to show us what VLANs we've created, and it already has these defaults down here that we've talked about. And it's going to show you what interfaces are assigned to those VLANs, or vice versa. Those VLANs are assigned to which interface. And notice here, VLAN 40 got created when we were in the sub interface mode, and there's no name for it. That's because we didn't give it a name like we did with VLAN 55 here when we got into the sub VLAN configuration mode. And then, of course, we have our show VLAN, which gives us the full VLAN database, which really, I mean, it's kind of silly. Show VLAN brief gives us all the information we need. All right. So thank you for viewing the lecture part of this video. Stay tuned when we go over our first VLAN lab.